So we are starting at, they took my paper for moderation. Is that a good thing or a bad thing? Can we do grade 9 work, please? We can. Honestly, Uma, grade 9 is not much different from this. You're still gonna do equations. It's just gonna be harder. But the concepts that we're building now, it's the exact same. You're still gonna do equations. You're still going to do expressions. You're still going to do exponent rules. All of it is the same. And I did show you the one new grade 9 rule. So that's that. Geometry, all your straight line geometry is pretty the same. Similarity, congruency, the same. It's just obviously at a higher level. Whereas now they were giving you sort of basics, just so that you can get used to it. In grade 9, they ask you like more difficult things, but on the same concept, same topics. Cool. So on that note, we have this equation here. I'm not sure really what my first step should be here. Does somebody want to tell me? I'm looking for my calculator. I don't see it. Isandile, yes.
Ma'am, you should see if you have like terms, or you should do distribution.
100%. So let's do distribution because I see some brackets and I want to get rid of those brackets. So I'm going to go 72 is equals to 6x plus 6. Now, remember, goal of an equation, get your variable by itself. So the first thing I want to do is move my loose terms. And right now I see a loose 6. So 72 minus 6 when we transpose is going to give me 66, if I'm not mistaken, equals 6x. Now that I've got this, again, I want to get my variable by itself. Oh, sorry, my tongue is actually crying right now. I want to get my variable by itself. Yes, no, imihle.
Hello, ma'am.
Hi, imihle.
So to get the variable, to get the x long, we have to divide both sides by 6.
100%. And what do we
So
get?
therefore, 11 is equal to x, and then x is equal to 11.
Beautiful. Thank you very much, you guys, for helping me with that one. Now, I want to show you something a bit more advanced. Uma, you asked for grade 9 work. I'm going to show you something that you might use in grade 9. Now, what we teach you to do this in grade 8, always distribute to remove brackets. We're getting you used to the basics. Now that you guys are used to the basics, I want you to think about what this equation means. 72 is equals to x. No, equals to 6x plus 1. What does that mean? This is multiplication in here, right? So really what I could do is to remove my brackets, I could have divided by 6 from the very beginning. And 72 divided by 6 gives me what? Yes, Imihle.
12, ma'am.
It is 12. And now what happens here is you'll see the multiplication by 6 and the division by 6 cancels. And so all that's left on my right-hand side is x plus 1. Transpose your 1, you get 12 minus 1 equals x. 11 is equals to x. This is definitely the quicker way, but this is what we've been taught to do in grade 8, just to get used to the basics. So as you move on, you'll see that sometimes when you have these brackets, it's easier to just divide by whatever's outside the brackets than to actually do the distribution. Now, what I want you guys to know is the only reason this worked is because when I divided 72 by 6, it gave me like a nice whole number. So it didn't make my equation overly difficult. So it sort of depends on the equation. If the answer you get from here is going to stay as a fraction and be all weird and confusing for you, then obviously you're not going to do it. Then it will just be easier for you to do distribution like this side. But if whatever's outside the brackets can divide nicely into what's on the other side, then this is the easier method that you're going to use. Cool. So that one's that. We're looking now at our next 3 over here. We have 2x over 3 minus 1 is equals to 15. Now, I see a fraction and I don't really know, but I don't know. The first thing I can see is that x is up here. So I'm going to make my life easier. And before I think about the fraction, I see a loose term. Let me deal with that. That is going to leave me with 2x over 3, which is equals to 15 plus 1, 16. Now, what I want you guys to see is there are 2 methods that we could use here. Now, the one method is this. It's equals to 16, but 16 can also be written as a fraction, and that is 16 over 1. When we have 2 fractions that are equal to each other, what we can do is we can cross multiply, and those will become equal to each other. So 2x times 1 is 2x, and 3 times 16 is, what is 3 times 16, somebody? Emilia?
48, ma'am.
Beautiful. Thank you very much. It is 48. And now, I see your hand is still up, Emilia. Do you want to solve the rest of it?
Yes, ma'am. So then we can divide both sides by 2,
Beautiful.
and then x is equal to 24.
Thank you very much. So that was method number 1. The other method we could do is 2x over 3 is equals to 16 over 1. Remember now, when we have fractions in an equation, what we want to do is we want to get every single term, whether it's on the left-hand side or the right-hand side, we want to get every single term to have the same denominator. And once we have the same denominators, we can then drop our denominators. Because if you think about it, think about what an equation is. An equation is really just a statement that tells me 2 different things are equal to each other. So if I'm telling you block over 3 plus block over 3 is equals to block over 3, it means that if I erase all of these denominators, the answer is still going to be the same, right? Because my numerators have to work out because my denominators are all the same. So in an equation, you get all your denominators the same, and then you drop them. Yes, Uma?
Now can I answer the next fraction 6.3?
Yes, you can. Let me finish up here then. So if I want to get this fraction over here to have the same denominator as the other one, which is 3, I'm going to multiply this by 3. But now remember, what we do on the bottom, we must do on the top. Okay. And we are then going to go ahead now and say, well, this is 2x over 3, which is equals to 48 over 3. Now that they both have the same denominators, drop your denominators. 2x equals 48. Divide by 2 and you'll come back to 24. So 2 different methods, same answer. Whichever one makes sense to you, use that method. Uma, we are looking at 6.3. Yes.
Denominator is the same, so you can drop the bases, and then you can just say 2x is equals to 2 to the power of 5. The bases are the same, so you can take that out, and x is equals to 5.
Beautiful. 100%. Thank you, Uma. So Uma said over here, and I'm going to just erase this step. Uma said our denominators are the same. So it's like what I just explained. Once our denominators are the same, we can drop our denominators. And what that must mean is that 2 to the power of x must be equal to 2 to the power of 5. Now, when we have a variable in our exponents, what we always want to do is get our bases the same. Now, if you've forgotten, we have what we call a power The entire thing here is called a power. This big guy is called the base, and my little guy is my exponent. Okay, so we want to get our bases the same. And so here in this equation, our bases were already the same. And so immediately, as soon as our bases are the same, then we know, well, my exponents must be equal. X must be equals to 5. And that was how we got that answer over there. Let's look at 6.4. We have the cube root of x, which is equals to 2. I really would like somebody to help me with this one. Anybody have any ideas? Maybe just point me in the right direction. Yes, Uma.
You want to get rid of the cube root, so you have to cube both sides. So on one side, that cube root cancels out, and 2 to the power of 3 is 8. So x is equal to 8.
Thank you very much. That was beautifully done. So let's remember, whenever we are solving equations, we want our variable alone. Right now, my variable is almost alone, except that there was a cube root stuck to it. How do I remove stuff that's attached to my variable? I use inverse operations. What is the inverse of a cube root? Well, it's a cube. What you do on the one side, you must do on the other side. And that is exactly what Umar did. He cubed both sides. On my left-hand side, cube root and cube canceled each other out. We were left with x, which is now equals to 2 cubed, and x is equals to 8. So that was beautiful. We now have oh my gosh, I didn't even read this question. My name. Okay, let's see what I'm doing here. 3 friends, Janet, Carrie, and Simone, go out for dinner. Janet spends twice the amount Carrie spends. Simone spends 60 Rand less than Carrie. The total amount they spent was 740 Rand. How much did Carrie spend? Okay, a lot of info. A lot of info. So let's whenever we have these word problems, we're always going to make our unknowns variables. Okay, so let's call Janet X, let's call Carrie Y, or not the people, but let's call the amounts that they spent. Let's say Janet spent X, Carrie spent Y, and Simone spent Z. Let's not try to create some equations with the info. It says Janet spends twice the amount Carrie spends. So this amount that Janet has spent, her spend is equals to twice the amount Carrie spent. Okay. Did we all follow how I created this equation in purple? Use your reactions, let me know. Janet spent twice the amount that Carrie spent. Okay, we're following there. Then they're saying that Simone spent 60 Rand less than Carrie. Okay, so what I spent is, my spend is equals to Carrie's spend, which is Y, less 60. So if I take Carrie's spend and minus 60, I'm going to get what I spent. Okay, so we have this over here. Now, what they're saying is when you add up what everybody spent, the total was 740 Rand. Now, immediately I'm like, there's three variables here. What am I supposed to be doing? And so what I'm going to try to do is I'm going to try to create one equation, and I'm going to try and write them all in terms of one variable. What I'm seeing in this equation, there's a y, and in this equation, there's a y. So let me try and make y the subject of both of these formulas. Now, when I say make y the subject, I just mean put y by itself on the left-hand side. So if I were to put y by itself over here, I would need to divide by 2, and what I would get is that y is equals to x over 2. Okay, and oh no, I'm lying to you. We're not getting y by itself, but we know what y is. We know that Kerry spent y. I want to get x by itself, and in this equation, x is already by itself, so that is perfect. Now over here, I want to get z by itself. Z is by itself, so that's perfect. What I'm doing now is the total we all spent together is 740. Terry spent Y. She spent the amount of money she spent. Plus Janet. Janet actually spent 2 times Kerry's amount. And Simone spent Kerry's amount less 60. So when we add up all the amounts we've spent, it's going to give me 740 Rand. Are we following how I created this equation over here? Imithle is with me, Uma's with me, Liacho is with me. Sometimes I want to ask you guys, I want to be like that person on TikTok that is like, explain the joke, you know? You guys are giving me thumbs ups. I want to ask you, like, explain what I said. Because I sometimes feel like you guys are just saying yes, even though you're very, very lost. But anyways, I'm gonna take what you've said as the truth. I'm now just simplifying this equation. Y plus 2y is 3y, plus another y is 4y minus 60. Yes, Itandile?
Ma'am, can I help you?
Mm-hmm.
Okay. Ma'am, you're gonna say 740 minus 60 is equal to 4y.
Are you sure
And
it's
then,
minus?
oh, it's plus 60, ma'am,
Mm-hmm.
which is equal to 4y. That means it's 800, ma'am. And then it's equals to 4y. Then 800 divided by 4, and then which is 200. Because we divided both sides, so it's going to be equals to y.
There you go. Thank you very much. And so now we've solved this equation and we said y is equals to 200. Now, if this doesn't make sense to you, the other way you could have done this is you could have said, well, 740 is equals to x plus y plus z. Why? We said that the total amount they spent was 740. So x was Janet's spend, y was Kerry's spend, and z was Simone's spend. And so if I add up all of our spends, it should give us 740. But what I then did is literally I substituted. So where I see X, I'm going to fill in. Where I see X, I filled in 2Y. Where I saw Z, I filled in Y minus 60. So have a look at this. Let me go. I said x was 2y plus y, which was just y over here, plus z, which was y minus 60. So it was really just some good old substitution, and then we were able to solve that one. So let us look at question 7, and I'm gonna zoom in some more. Let's look at question 7. So they've asked us to fill in the boxes. Okay. And what we are going to do is we're sort of trying to see what's happening over here. We have -2 and it's flowing. It becomes 4 minus x. Okay. So I'm seeing what we're doing. We are substituting. They're giving us a value. They're giving us an equation. And then we have to substitute. So over here, what I'm basically doing is giving the answer. So this is 4 minus. And if I substitute -2 in for x, what is my answer going to be? What is 4 minus -2? It is 6. Over here, I don't know what x is. I don't know what the answer to x is. Remember, these are basically the answers to x. These are not the answers to x, but these are the values of x. These are my equations. And then over here is the value of the entire equation, not just x. So over here, I have the value of this entire equation and I have the equation, but I don't know what x is. So what I can do is I can say, well, x squared plus 1 is equals to 5. And now I'm simply solving this equation for x. That's going to be x squared is equals to 4. Square root both sides. And then x is equal to 2. Okay. So that is that. So over here, my value is going to be 2. Use your reactions. Let me know. Are we following what's happening over here? Uma is with me. I can even ask you guys by name. Unati, are you following? Kandila is following. Unati is following. Who else was in class? Entle, you with me? Entle is gone. Liaku is gone. Oh my gosh, there's like 1, 2, 3, 4 of you left. Okay. Okay, that's that. And then over here, can you guys give me this last answer, please? And I think if we finish question 8, we will do a brain break. I'll find one for us. Yes, Itandile.
If I'm not mistaken, ma'am, it's 0, no, it's 1. No, I'm lying. I'm lying.
Actually, don't know. I feel like it's gonna be bigger than 10.
I think I'm lying, ma'am. I think I'm
Yeah,
lying.
you are lying. Put it in your calculator.
Oh, ma'am, it's 100.
There
I
you
just
go.
missed 1 0, ma'am.
It is 100. So that was nicely done. I see Liako's joined us again. Welcome back, Liako. Ma'am, I'm having serious Wi-Fi issues. I'm sorry, Liako. We're about to do a brain break though, so hopefully you get to join us for that. Let's see how long is question 8. Kind of not so long. I'm sure we can finish it. Let us look at question 8. So it says 5 marks. Joe plotted the equation y is equals to 4x plus 18 by using substitution and a table. The table shows his answer. So a lot of words that might be confusing. All that happens is this is the equation. He plotted a graph on the Cartesian plane. He used a table and he substituted his x values into his equation and filled out the answers. Okay. Now 8.1 asks, how can we tell he did something wrong by looking at the graph? What do you guys think? How can we tell? Ritandila, your hand is up.
Ma'am, I'm sorry, but I'm still trying to think though.
That's okay. Anybody? the points do not form a straight line. Okay. That is how we know he's done something wrong. Remember, guys, at this stage, the only graphs you are going to come across are straight line graphs. Now, when you get to grade 10, you'll learn all about different kinds of graphs. But for now, what you guys should know is that this is the equation for a straight line graph. Do his points form a straight line if I join them up? No, they don't. And so immediately I know he's done something wrong, because in my mind, and remember what I told you guys, in my mind, I know my points should join up to form a straight line. And the minute they don't, I know I've done something wrong, go back and check. So that's how we know that he did something wrong. Now, it says that Joe has made mistakes in the table and on the graph. Locate, correct them by filling in the table below and by plotting and connecting the correct points to create the graph on the Cartesian plane. So basically, we're redoing his work. Okay, let's copy our equation. Y is equals to 4x plus 18. Imihle and Itandile, I hope you guys are paying attention. Y is equals to 4x plus 18. So, how do I fill in these blocks for y? How do we fill in my blocks for y? What am I going to do? Anybody? Uma? Yes, Imihle.
So, ma'am, what we're gonna do is we're gonna say we're gonna say 4, and then in brackets we're gonna substitute the x for -5, and then say plus 18.
Beautiful.
So the first one is going to be -2,
Correct.
and then the second one is gonna be 2.
-4 plus 18. Let me double check you. 4 times -4. -16 plus 18. Correct. That's now +2. Last one.
And then the last one is 6, ma'am.
Plus 18. So that is going to be -12 plus 18. And it is 6. Correct. Okay. Now, do you want to help me with plotting? Okay. Let me think. Okay. I'm thinking, I know I have my Cartesian plane. I know I said y to the sky, so that means this is the y-axis, this is the x-axis. What else do I know about Cartesian planes? I'm thinking. I know that we can write coordinates in a Cartesian plane in the format x and y. And I know if I have a table, I can create my coordinates. My x value, when my x value is -5, my y value is -2. When my x value is -4, my y value is 2. And when my x value is -3, then my y value is 6. Okay, so that's that. So now I have some coordinates, and now I need to start plotting. Well, they've told me up there is 10, and down here is 10. No, down here is -10, and here's -5, and this is 5. So it's going to be a bit of a weird graph because they clearly haven't used the same scale, but that's fine. I know this is going to be 1, 2, 3, 4, and 5. Okay, so that's -1, -2, -3, -4, -5. I know this is 1, 2, 3, 4, and they've labeled 5 for me. This is probably going to go in twos. So this is going to be +2, +4, +6, +8, and +10. So you can see they place this a little bit skew on the grid, but we'll leave it. This is now going to be -2, -4, -6, -8, and -10 down there. Now let me go ahead and plot my points. The first thing I want to do is I'm always starting with my x value. So x-axis over here, -5 is here. And when my x value is -5, this is my -5 line. My y value is -2. This on my y-axis is -2. So I sort of join the dots, and this is now where my point is going to be. Let's draw the next point. It is -4 and +2, so that's up here. And last point, -3, and then +6. And immediately, guys, do you see this looks so much better because it is going to join and form a straight line. Okay, so obviously this thing doesn't like to listen. There we go. Okay, are we happy with question 8, you guys? Okay, so let's go into a brain break. Let me go and look for one. Let's go back. I actually don't even know where we stopped. I think we passed that. This was patterns. That was that. Oh, yes, we did this. So that was that. Okay. So remember, we're doing one must stay. So, immediately, one must stay at the movies. Popcorn, cold drinks, slushies, sweets.
Honestly, ma'am, out of all of these, I really don't know which one I would keep because, like, I like all of these, but I'm gonna have to say popcorn now because I really love popcorn.
I think I'd have to agree. Like, you can't, the movies is not the same without popcorn. So
Yes, ma'am.
I'd have to say popcorn. Unati, what is your take?
Ma'am, I disagree with the popcorn. I hate popcorn.
Oh,
It gets
no.
stuck in your teeth,
It
and then
does.
whenever you put that like the spices on it, when you get to the bottom, it's too salty. I hate popcorn. So like I think the slushies should stay because like I don't know. I love drinking
Mm,
beverages when I'm watching movies, but like I hate popcorn.
that makes sense. The thing is, though, like, something about specifically the new Metro butter spice, it's like insanely good to me. I don't know how and why I find it so good, but I like that thing has me addicted. If it was a drug, I would be an addict. That's all I'm saying. Um, this is one must go. So it was previously one must go, but we're playing it as one must stay. So don't do one must go. We're playing it as one must stay. Leah, do you want to answer the same one?
Sorry, ma'am. You lagged out there. I didn't hear you.
Do you want to answer this one or the next one?
Ma'am, the next one.
Okay, cool. Uma, you this one or the next one?
I'll answer the next one.
Okay. Uma, I very specifically remember you answering this, and you said one must go. I feel like we did this one before, man. I think we did one must stay with this. Because, Uma, I remember you saying yogurt. Am I wrong?
No, but I'll choose milk.
Oh, you choose. Okay, so we didn't do it. Okay.
Protein.
Why are you choosing milk?
Protein.
Makes sense. You're such a
And it
germ.
has a lot of calcium.
Mm. Yeah, I'm like a super big dairy fan. So
And plus
Mhm.
protein shakes.
true. But you can do like protein shakes with yogurt. I mean, come on. Like yogurt and water,
Yeah,
you know?
but like milk, it's like you can just take protein powder and mix it with milk.
True. Um, what was I gonna say? We have done this before. Like, I'm getting deja vu anything. I'm not sure. I think we did do one must stay with this, or maybe I'm just remembering the one must go. But anyways, Liaho, do you have an answer for this one?
Ma'am. Okay, ma'am. Is this one must stay or one must go?
One must stay.
One must stay. Ma'am. I think I'm actually gonna go butter, ma'am, because I like butter. Like, ma'am, Rama's the best, ma'am.
Same. For me, like I like butter, like like butter, like the butter you get when you like go out to like Ocean Basket and they give you like those little tubs.
Oh yeah, those ones. Yeah.
Yeah, crazy. It is so good. Like butter, it's like stuff of my dreams.
Yeah. Yes, ma'am. True. True.
I put butter in everything I eat. So
Same,
I
ma'am.
think, yeah, right. Like I think I might have to go with butter, but I also like cheese so much.
That's the thing, ma'am. That's the thing.
These things are too hard. I'm moving on. Does anybody else want to answer this one? There's so few of us. You guys can all answer it if you want. Anybody?
Ma'am,
Mhm.
ma'am, milk. You get like, ma'am, milk goes into stages. You get yogurt, you get butter, you get cheese. So, ma'am, why don't y'all just pick milk and make your own pasteurized yogurt that can make your own butter and cheese? This is the same thing.
I
This is
get it,
literally
right?
the
But
same
I
thing.
don't I don't have the brains or the skill to make yogurt, butter, or cheese, like
Wow, man. But then all of this is made from one thing,
it's
milk.
all dairy,
So
and
you
like
see,
we know. But you
ma'am,
have to
you
have
also
the skill. And also I'm sure machines do it better than like handmade stuff. Let's be honest.
oh wow, ma'am. So like you can go for takeaway food instead for homemade food.
Yeah, because if somebody had to offer me homemade butter or homemade cheese, I'd probably say no, thank you. I'm not gonna lie.
Wow, ma'am. But then,
Think
ma'am,
about
I
it,
feel like,
Itagile. If somebody offered you homemade cheese, would you eat it?
ma'am, I don't know if they put poison in it though.
You don't know what they did. Like this is milk that they fermented. You don't know. Like no, there's no way. We'll leave it to the professionals. I
So
am gonna go.
you trust the people from the machines. So what if they put poison in there
They
and
could.
you have to easy, ma'am?
They
There's no
could.
difference. There is no difference than making homemade butter because someone can still put poison in the batch.
But the difference is it's not about the poison. It's that the people who actually manufacture it, they have like machinery and stuff to make sure that everything is done properly. Yeah, in my house, I don't have like like thermometers and whatever else you need to make butter or cheese. Like I don't know. I'm just doing my own thing. So no, 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 no.
Okay, ma'am. My comment is like we can disagree and agree, but ma'am, I don't agree on this one.
I can see that, Ethan. There. Even Unati is like the fact that nobody's picking cheese is killing me. Unati, I know. I love cheese. I just like dairy in general. So it's really hard. Um, I suppose I'll let the guys take the lead with this one. Yes, Umar.
Um, I'm picking between Mercedes and BMW now. I'm thinking Mercedes. Yeah, no, BMW. Yeah, BMW.
Makes sense. A lot of people are BMW fanatics. Yeah, so makes sense. So Leah, for you,
Ma'am, I think I'm actually gonna pick Audi, ma'am, because it's my favorite car. But Mercedes is also a bit more iconic. BMW, yeah, but it's okay, man. BMW is nice. It used to be my favorite car, but it's actually Audi.
I think I might agree with that. Just because I feel like the other people's like this is it's for nothing else other than like other fanatics, like BMW fanatics, Mercedes fanatics, VW fanatics. They somehow annoy me. I don't know why. I just don't understand like how you can be so obsessed, I'm
Yeah,
just I'm just like stop. Stop. So I think I'd also say Audi must stay just to get rid of all the other people.
yeah, ma'am. I see you, ma'am. I see you.
Immediately, what are we saying Audi wrong?
No, ma'am. It's just like like people that I know like at school. Like some people pronounce it Audi, some people pronounce it Audi, and like
Mm.
it's just
I mean,
I don't
I
know how.
see the Audi because if it was an O, then it would be audio. Ah, I never thought of it, but I've just always called it Audi. So I'm gonna go ahead and say Audi is correct.
Thank you, ma'am.
Yeah, the Apple agrees. Girls, do you guys want to answer this one? You guys can talk freely.
Ma'am, I don't know how. Ma'am, to be real, I don't know the difference between a Mercedes and a BMW. I don't know the difference, but you know what? I'm just gonna go with Audi just to be safe. I
Nice.
just
Go with
don't
the
like.
team.
This time I agree with that. This time I agree with that. Other
Nice.
times I didn't. This time I do agree.
Thanks, Itanile. You, Nati?
Ma'am, I'm listening to all these people pick Audi over BMW, and I am disgusted. BMW is the best car ever. I know it's not because my mom drives one, but it's just genuinely the best car ever.
Like, how do you differentiate? Unatine, I don't know how to differentiate between a Mercedes and a BMW. So like, you're just like picking the same obsessed car, but then the only thing that changes is like the logo.
No, it's not like that. Okay, see. So, a Mercedes and a BMW are not the same car, ne? Because a Mercedes is like, okay, cool, it has the comfort and stuff, but like BMWs are like fast, and like there's fast Mercedes cars, but like a BMW is just like it's that sport car, so like it's just a better option. It literally just is the better option,
I get you, ne? Which is
right?
great. Fine, I get you.
I'm like, I get it, but I also don't. I'm like, at the end of the day, it's just a car. Like, it's going to take you where you need to go. It's, it doesn't matter. Okay, guys, back to maths, back to maths, back to maths. Thank you for all. Thank you for participating. We have question 9. This is something we have not done together. I think it's transformation. Let's see. Study the figure, answer the questions that follow. So let's look at that. Let's go. Oh my gosh. I forgot I did that. Oh my gosh. Okay. Give me a second. Let me open this thing up again and get us the question. Um, this is very annoying right now. I think it's this one. Yes, it is. What is that? Question 9. There we go. I think this will be all we'll do today. Because end of class is quickly approaching, so. Sorry, I literally froze there. I was looking at my screen and I forgot what I was supposed to be doing. Okay. Let us have a look at this. Oh, that's huge. And let's actually even just put it up here. Okay. So they are saying 9.1, use the graph to help fill in the table from A to B. So we're going from triangle A to triangle B. What is the transformation? Now, there's multiple different transformations. We can have a translation. That's when you just move your shape. You can have a rotation. That's when you turn your shape around. You can have a reflection. That's when you do almost like the symmetry mirror kind of thing. I'm trying to think what else there is. And Uma has gotten it. It is a reflection. Okay. So this, if we're going from triangle A to triangle B, we have literally reflected this. If you think about if a mirror were here and you would place the mirror here. I don't know if you guys have ever done this like activity. I remember it really helped me like think about symmetry and think about this topic of translation, where if you put a mirror on something and you look through the mirror, it's literally a reflection, and that is what is happening over here. Think about if I were to fold this piece of paper exactly on my axis. What would happen is those two triangles would come and be exactly on top of each other. And that is basically what happens when we have a reflection. So the transformation from A to B is specifically a reflection. Now we're starting at triangle D for the next one. So we're starting here. And then the transformation is, it's a translation 3 units right and 4 units up. So what we do when we're trying to translate a shape is we take 1 point. And now we're going to go 3 units to the right, which is 1, 2, 3, and then 4 units up. 1, 2, 3, 4. Okay. And I can see this point. Now, if I had to do that with every single point, you'll see that it forms this triangle A. And so from D to A is now the translation 3 units right and 4 units up. Itandile, your hand is up. Was it still up from the brain break, or do you have a question?
Ma'am, I don't have a question, but I can answer.
Okay, do you want to answer the next one?
Yes, ma'am.
Mm-hmm.
Ma'am, it's E.
It is E. So tell me how you got there.
Oh no, ma'am, it isn't. It's D. It's D.
It is D. Specifically because be careful that they said it's a reflection over the y-axis. So if they say something like that, I want you to think of if you were folding along your y-axis. If you were folding along your y-axis, where would this triangle end up? It would end up right on top of triangle D. See that, Itandile?
Yes, ma'am.
Thank you for answering. And last one, from A to G. Is Intle still here? Nope. I was gonna say this was gonna help with paper 2 tomorrow. But anyways, now we're going from A to G. We're saying rotation, and that's correct. This is going to be a rotation. Because if I think about it, it can't be a reflection. If I were to fold it, it's not gonna be that. If I were to translate it, it's not gonna be that, because my triangle still has to stay upright if I'm just translating. And so the only thing it can be is a rotation. And so that is that. There is 1 minute left. Let's see if we can do 9.2. It's asking us to enlarge triangle D by a scale factor of 2 through the origin. So triangle D, enlarge it by a scale factor of 2. When they're talking about a scale factor, all that they're saying to you is that you have to make it 2 times bigger. And so you're going to enlarge it through the origin, meaning you are going to still keep it in the same place in relation. So here, if it's now 3 blocks away from your origin, you're now going to make it times 2. So you're going to make it 6 blocks away. And if it is 2 blocks, or rather it's 1 block up from my axis over here, I'm going to make it 2 blocks higher. The length was 2 units. I'm not going to make it 4 units. And this length was 3 units. I'm now going to make it 1, 2, 3, 4, 5, 6 units. And I can join it. And so that is now last question for today. I have gone and I have enlarged my triangle D and by a scale factor of 2. Okay. That is that, guys. Lots of W's in the chat. Thanks, Umam. And